Have you ever, just stared up at the night sky and felt completely tiny, maybe wondered, how far does it all go? Where does it stop? Or does it even stop at all? Well, today, you and I, we're not just dreaming about it. We're actually doing it. We're setting off on, well, the greatest journey you could possibly imagine. A journey right to the edge of everything we can see, the observable universe. And naturally, we start right here, home, Earth. It's really the only home we know, isn't it? This fragile blue marble just sort of floating in this massive black ocean of space. We're orbiting a pretty ordinary star in a fairly average galaxy, and the universe itself is just way beyond our comprehension, really.
It's hard to even get a sense of the scale. I mean, try this. If Earth were a marble, the sun would be like a big beach ball.
Yeah.
And it wouldn't be close. It'd be, 24 meters away from that little marble.
Well, that helps visualize it a bit, but it's still staggering.
And that's just our tiny backyard. We are not stopping at the sun today.
Oh, no.
Oh.
Wow.
We're going much, much further out. You're absolutely right. The scale, it just explodes immediately. And to even begin this kind of trip, we need to talk about speed, like unbelievable speed, the fastest speed possible, really.
The speed of light.
Exactly, the speed of light. That's about 300,000 kilometers every single second.
Wow. Per second.
Per second. To give you a feel for that, you could zip around the Earth more than 7 times.
At 1 second.
In just 1 second.
That's almost impossible to imagine. 7 times. And still, even going that incredibly fast, it would take us, 4 years? Just to get to the next star over, Proxima Centauri?
4 years, yeah. At light speed.
And then 100,000 years just to cross our own galaxy.
The Milky Way.
That's the scale we're dealing with. 100,000 years.
Okay, so consider this your official welcome to deep space.
Yeah.
Right, so as we keep going, this first part of the journey, we're whipping past the familiar stuff. Mars, Jupiter, Saturn, way out there.
The gas giants. The Neptune, Pluto. They're just tiny dots behind us now. But we don't stop there. We go further, past the Kuiper Belt, where all those icy dwarf planets are.
Right, beyond Neptune's orbit.
And then we plunge even deeper into this cold, dark, icy wilderness. The Oort cloud.
Yeah, the Oort cloud. It really feels like the final frontier of our solar system.
It does, doesn't it?
Yeah.
Just vast emptiness.
It absolutely is. And it's out here, floating in that dark silence. That's where we'd find a little piece of home, actually. Voyager 1.
Ah, Voyager. Still going.
Still going. It's the farthest thing humans have ever sent out. Still sending back these tiny signals after decades.
Amazing.
But what's really incredible about Voyager 1, it's not just how far it is. It's carrying something. That golden record.
The golden record, right. The sort of time capsule.
Exactly. It's got greetings in 55 languages, music from all over the world, sounds of nature, pictures of Earth.
Wow.
It's like this. This message in a bottle, tossed into the cosmic ocean, set out just in case someone or something finds it someday.
That gives me chills, honestly.
Me too. It says so much about us, I think, that need to reach out, to connect.
Yeah. Yeah, it really does. Imagine someone finding that billions of years from now. Okay, so we keep zooming out, further and further. And now, the stars, they don't look like individual points anymore, do they? They start looking more like grains of sand, scattered everywhere.
Just countless points of light.
And some are these blazing giants, super bright. But others, we realize we're seeing the light from stars that are already gone. They've already died.
Yeah, their light is still traveling, but the star itself burned out maybe millions of years ago. It's a humbling perspective.
Definitely humbling.
And amongst all those stars, you start to encounter some really weird and wonderful things, like pulsars.
Pulsars, right. Those are the really fast spinning ones.
That's them. They're neutron stars, incredibly dense. Basically, the leftover core of a massive star after it explodes.
How dense are we talking?
Okay, picture this. They're maybe smaller than a city in size.
Wow.
But they weigh more than our entire sun.
That's hard to process. More than the sun in the size of a city.
Exactly. It's matter crushed down to an unbelievable state. They spin super fast, flashing like these cosmic lighthouses.
Okay, wow. And then there's a really big one, right, at the center of our galaxy.
Yes. The monster in the middle. Sagittarius A star.
Which is...
That's a supermassive black hole.
Supermassive? How massive?
About 4 million times the mass of our sun.
4 million suns crammed into a black hole.
Yep. And it's the anchor. Its gravity holds the whole Milky Way together. Everything orbits around it, including us.
Incredible. An unseen force just holding billions of stars in place.
Yeah.
Okay, but we're not staying in the Milky Way. We keep going. Our galaxy, by the way, is just one of maybe 50 or so in what we call the local group, our galactic neighborhood.
That's right, a little cluster of galaxies.
And as we press on, we see another huge one coming towards us, Andromeda.
Our nearest big galactic neighbor, a giant spiral, much like ours.
And it's actually heading right for us. You mentioned it's racing towards us.
It is, at about 400,000 kilometers per hour.
Okay, hold on. Racing towards us. Are we going to collide? Is that cosmic disaster looming?
It sounds dramatic, doesn't it? And yes, in about 4 billion years or so, Andromeda and the Milky Way will merge.
Merge, not crash.
Well, collide, merge.
Yeah.
But here's the key thing, the bit that's hard to picture. Space, even inside a galaxy, is mostly empty.
Right.
So when the galaxies collide, the stars themselves, they're so incredibly far apart, they probably won't hit each other.
Really? They'll just pass by.
For the most part, yes. They'll pass right through each other. The gravity will mess things up, orbits will change, the structure of both galaxies will be completely reshaped over millions of years, but it's less of a demolition derby and more like, well, like a cosmic ballet.
A cosmic ballet. I like that. Less alarming than a head-on collision.
Exactly. A gravitational dance on an unimaginable scale.
Yeah.
It really shows you just how vast things are.
Okay. Galactic slow dance. Got it. That's a relief for future generations. So, the further we go now, something else starts happening. We're looking further, but also older.
Precisely. This is the look-back time effect.
Look back time.
Yeah. Light travels fast, but not infinitely fast. So the light from very distant objects has taken billions of years to reach us.
So when we look at a galaxy that's, say, 10 billion light years away.
You're seeing it as it was 10 billion years ago.
Wow. Not as it is now?
Nope. You're looking back into the past. The universe isn't just wide. It's incredibly deep in time, too.
We're literally seeing ancient light. Light that's just now arriving after traveling across the cosmos.
It's like having a time machine just by looking up.
Incredible. So we keep going, looking further back in time until we reach
What?
the edge.
We reach what we call the edge of visibility. This is the boundary of the observable universe.
Observable universe, okay. How far is that?
Current estimates put it at about 46.5 billion light years away in any direction.
46.5 billion light years. But wait, if the universe is only about 13.8 billion years old, how can we see things that far away?
Great question. That's because the universe itself has been expanding the whole time that light has been traveling.
Okay. So the space between us and that distant object stretched out while the light was on its way.
Exactly. So the light traveled for 13.8 billion years, but the place it came from is now much farther away due to expansion.
Got it. So this edge, 46.5 billion light years out, is that like a wall, an end to space?
No, and that's really crucial to understand. It's not a physical edge. There's no sign saying universe ends here.
Okay.
It's simply the limit of how far light has had time to travel to us since the Big Bang.
So it's a time horizon, not a space boundary.
Perfect way to put it, a temporal horizon. There's almost certainly more universe beyond it, but the light from those regions just hasn't reached us yet, and maybe never will if expansion continues accelerating.
Fascinating. So right at that limit, that horizon, what do we see? What's the oldest light?
That's where we find the first light, what scientists call the cosmic microwave background, or CMB.
The CMB, I've heard of that. That's like the echo of the Big Bang.
Pretty much, yeah. It's light that was released just about 380,000 years after the Big Bang.
380,000 years. That sounds like a long time, but in cosmic terms.
It's practically infancy. Before that moment, the universe was different. It was this incredibly hot, dense fog, like a soup of charged particles, plasma. Light couldn't travel freely. Photons just kept bumping into electrons.
So it was opaque. You couldn't see through it.
Exactly, opaque. Then, as the universe expanded and cooled enough, electrons and protons combined to form neutral atoms. Suddenly, photons could travel freely through space without constantly scattering. And that's the light we see today as the CMB.
The universe became transparent.
Precisely. And this ancient glow, this afterglow of creation, it fills the entire sky in all directions.
Wow. How was it even found?
Well, that's actually a great story. It was discovered by accident in the 1960s. Two scientists, Arno Penzias and Robert Wilson, were working with this big radio antenna. And they kept picking up this faint, annoying background hiss. Static, no matter where they pointed the antenna.
So they thought something was wrong with their equipment.
Totally. They checked everything. They even cleaned out pigeon droppings from inside the antenna horn, thinking maybe that was causing the noise.
Doonchins.
Seriously.
Seriously. But the hiss remained. It turned out they weren't hearing faulty equipment or pigeons. They had stumbled upon the residual heat, the oldest light from the Big Bang itself.
Wow. They heard the echo of creation and thought it was bird mess.
Kind of poetic, isn't it? Sometimes the biggest discoveries are just waiting there, disguised as noise. It was huge confirmation for the Big Bang theory.
Absolutely incredible story. Okay, so we've journeyed to the CMB, the edge of what we can see, the oldest light, which brings us back to that huge question. What is beyond that edge, beyond our observable horizon?
And yeah, that's where science meets speculation, really. It's still a massive mystery.
We just don't know. We have ideas, theories, but no direct observational evidence yet. Our sources hint at possibilities. Maybe it's just more universe, more galaxies, more stars, stretching on perhaps infinitely, just like the part we can see.
Okay, that seems plausible. More of the same.
Or
Yeah.
maybe eventually,
Yeah.
there's truly nothing, a genuine void beyond the expanding bubble of space-time we inhabit.
Nothingness. That's hard to imagine, too.
And then there's the really mind-bending idea, the multiverse.
The multiverse, infinite universes.
Potentially, yeah. The idea that our universe is just one bubble among countless others. Maybe these other universes have slightly different laws of physics, different constants.
Leading to completely different realities.
Exactly. It's highly speculative, driven more by theoretical physics than observation right now,
Yeah.
but it's a possibility.
Wow, a multiverse. So somewhere out there,
Yeah.
maybe in another bubble universe, there could be another version of you listening to this very same deep dive. Or maybe a version where pigeons did invent radio astronomy.
Maybe. It certainly expands your thinking, doesn't it?
It absolutely does. Which kind of leads to another question. Why? Why do we do this? Why pour so much effort into exploring the cosmos, trying to reach these edges, asking these questions about things so far away?
That's a fundamental question about human nature, I think. Why explore at all?
Yeah.
We dedicate huge resources, brilliant minds, decades of work to understanding things that seem so abstract, so disconnected from daily life.
Right. What's the point of knowing about Sagittarius A or the CMB?
But I think the insight, the reason we do it, is actually incredibly profound. It's because the more we understand the universe out there, somehow, the more we understand ourselves right here.
That's beautifully put. It makes me think of Carl Sagan.
Sagan. Yes.
Didn't he say something like, we are a way for the cosmos to know itself?
He did. Such a powerful idea. That consciousness arising here on Earth is the universe becoming aware of itself.
We're made of the same stuff as stars.
Exactly. We are literally stardust, forged in the cores of ancient stars billions of years ago, now somehow imbued with consciousness and curiosity. Well, that seems to be our built-in compass. It just drives us to explore, to understand our origins, our place in this vastness.
So we've traveled together, in our minds at least, right to the very edge of what we can currently see. We've stretched our understanding of space and, maybe more importantly, of time.
Yeah, we've reached that boundary defined by the oldest light. But, the journey,
Yeah.
it isn't really over, is it?
How so?
Because human ingenuity doesn't stop. With every new, more powerful telescope we build, like the James Webb, with every new theory, every clever observation, we push that boundary. We try to peek just a little bit further.
We extend the edge.
We extend the edge, exactly. We refine our understanding of the CMB. We look for clues about what came before, what might lie beyond. The universe is still out there, waiting, holding its secrets.
So the message is, keep asking questions.
Absolutely.
Keep being curious, and maybe keep looking up.
Definitely keep looking up.
Because this journey to the edge, maybe it really is only the beginning.